Our Physics 212 project is the building of a replica of a trompe. A trompe is a device that uses energy of falling water to create pressurized air, and it can harness the power of water without the need of energy use. In this process, pressurization is achieved through the water falling down a pipe. As the water drops, it draws air through a small inclined area that carries that air to a reservoir where the air is separated from the water and held underneath pressure. So let's get to the video where Luke explains the trompe he built.
Alright, Physics 212. For our group's project, we built a trompe, which is pretty much just, it creates renewable energy just with water flow, and renewable energy in the form of pressurized air. So the main way that this works is we have inflow, which could be a stream, river, anything like that, but in our case, we just have a hose right here, right? The water comes in through here, and what we have here is we have an elbow pipe we drilled holes right here, and we put straws and then glued the outside, so it's just the straws being let into the pipe. What's going on here is right here, the air is atmospheric, or the pressure is atmospheric, and we have this velocity going down here, and as we learned in our class, when velocity, it takes a little bit of energy away from the pressure, so the pressure is going to be lower down here, thus pulling the air into the water stream. And we can't exactly explain this with mathematics, what's going on here, but it works. So, as you can hopefully see from that far away, is we have water and air as a mixture as bubbles, and it's slowly going down this pipe, right? And then we have it teeing off, and as it tees off, the air rises to the top of the pipe, and to make sure that, so this right here is the storage for the air, and as we all know, air rises up because of its density difference. It's lighter density than water, or less dense, but we have this right here, this jump in area, and what we're trying to do there is, by the jump in area, what we're trying to do is lower its velocity to make sure that the bubbles stay at the top and separate from the water. And so, as you can hopefully see from there too, is we can see bubbles here, but there's no bubbles leaving. It's just water. So all the bubbles, or air, gets trapped within this segment right here, and over time, more and more air is going to get stuffed into that space until we get to a point to where it is an equilibrium of pressure, and that equilibrium of pressure is set by, as we know in our class, rho GH, which is set by that guy right there. So his height, well, technically both of their heights, but this one always has to be taller than the other one in order to create this this vacuum, or I guess not negative pressure, but less pressure than up here. So that height is going to be the one that sets the pressure of this whole system, right? Thus setting the pressure of the air entrapped in this space. Yeah, thank you.
Pushed out. So as you can see from our last video, is normally there's not any air on this side of the tube coming through here. But after enough time passes, this chamber gets filled up with air right here, and the pressure equalizes. So if there's no more pressure or energy that can be put into squeezing all the air into the space, it's going to start leaving right there. So with the system that we have built here, we have to release that air right here, and we can see that the air is gone from there. Yeah, there you go.
Okay, so here in the video where Luke is blowing up the balloons, as you can can see where the balloon is at, that's where the compressed air is coming out. And the air that's actually coming out of that location is actually colder because the cold water flowing through the trompe is absorbing the heat that usually is generated by the compression of the air. And it comes out drier because of the atmospheric moisture held in the air bubbles that flow through the system that's condensing, so to speak, on the bubbles wall where the white pipe is. And so the result of this, the compressed air that's the same temperature as the cold water is just left drier than when it is entered, and it's basically kind of like air conditioning in a way. And as you can see, when he's blowing up these balloons, on the right side of the video where the longer pipe is, when it's short, no compressed air is coming out, and then the longer the pipe is, the more compressed air you can actually get. Alright, so here's an example of a more advanced trompe that would be used in larger places and generally are used underground. And so an example of this would be ragged chutes in real life. It's a large-scale trompe, which is also known as a hydraulic air compression plant. And these type of trompes were built at the turn of the century to supply mines with fresh water. Small trompes were even used in aerating and treating mining water in remote places because you couldn't get electricity over there. And so the benefit of having a trompe was basically it had no moving parts and didn't rely on any computers, didn't make noise, and it didn't pollute the environment. So it was a great renewable form of energy, especially when you couldn't even get access to any form of electricity. And because of this, over in Ragged Chutes, they're still up and running and they're still there because there hasn't been anything that's been a better thing to change out. Like, there's no upgrade or anything that's more modern that could replace the large scale trompe that's over there in Canada.